To learn about decade counter. Okay, it is asynchronous decade counter. The output from decade counter, next we are going to connect to 7 segment display. Okay, so this is the pin diagram for decade counter. Okay, so where 2 and 3 are called as set inputs. Okay, 6 and 7 are called as clear inputs. Okay, so these inputs should be held at low to act this IC as a decade counter, otherwise it will not count in the order. Okay, it will stay at any one of the invalid state. Okay, so 14 is clock. Okay, since it is asynchronous, the output of previous state will be given as input for next state, means clock for next state. Okay, so that's why 12 and 1 is connected. Okay, so here A, B, C, D. Okay, these are all the outputs. So this is the truth table. Okay, so since it is decade counter, it counts 10 states. Okay, states are from 0 to 9. Okay, 0 to 9, 10 state. Then it will repeat, means after state 9 again it will start from the state 0. Okay, so this is continuous. Okay, 0 to 9 state, it counts in order. Okay, so this is the state diagram, you can see. So next we have connection for 7 segment display. Okay, so the pin used is IC is 7447. The output of decade counter will be given for input for 7 segment IC, means whatever the values we see in binary, the same values you can see in 7 segment form. Okay, so here you can see this is the 7 segment display. Okay, so here we are using common anode display method. Okay, so now we'll see the connection. Okay, so since we are using 2 IC 7490, this is decade counter IC. Next IC is 7447. Okay, it is 7 segment display IC. Okay, so first we'll check for decade counter. Okay, next the output of decade counter, we give input for 7 segment. Okay, so binary values we'll see at output LEDs. Okay, this is 7 segment. Okay, the same equivalent values we observe in this 7 segment display. Okay, so we'll see the connection. Okay, first we'll do connection for decade counter. Okay, so as I told, pin number 2 and 3, okay, these are set inputs, and pin number 6 and 7. Okay, so these are clear inputs. Okay, so these two should be held at low voltage. Okay, to work this IC as decade counter, hence we have to connect this to ground. Okay, just short 2 and 3, 6 and 7. Do the connection for ground. To give low voltage, we have to connect that to ground. Okay, so next pin number IC pin number 10 is also ground. Okay, since it is 14 pin IC, pin number 10. Okay, this is 10, which is connected again to ground. Okay, so in this IC, pin number 14 is given to clock. Okay, so here we have two clocks, one is TTL clock, another one is monopulse. Okay, so if we give to TTL, so it will give automatically. Monopulse means, okay, we user has to give the clock pulse. Okay, then only it will change the state. Okay, so next 5 is given to VCC here. So in this we have pin number 5 is VCC, pin number 10 is ground. Okay, so next we will do the connection for output. Okay, since it is 4-bit, okay, we consider QA, QB, QC, QD. Okay, in this order. Okay, so pin number 12 is QA. So this is QA. Next pin number 9 is QB. This is QB. Pin number 8 is QC. 8 is QC. And pin number 11 is QD. Okay, we have 4 bits. Okay, these are 4 outputs, QA, QB, QC and QD. Okay, since it is asynchronous, okay, so we have to give output of previous state as clock for next state. Okay, so we have to connect output of previous state as clock for next. Okay, next clock, another clock P is pin number 1. Okay, either you connect QA and pin number 1, or you can connect 12 and pin number 1, or you can short 12 and pin number 1. Okay, short pin number 12 and pin number 1. Okay, so this connection tells it is asynchronous. Previous state output we are giving as clock for next state. Okay, so here you can now you can observe the output. So we'll wait even sets to 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, after 9 again it will repeats. Okay, so it will count from 0 to 9. So it is a decade counter, so it counts in binary fashion. Okay, now we'll see the connection for 7 segment display. Okay, so for 7 segment display, so we are using the IC 7447. Okay, so this is 16 pin IC. Okay, remember till now we have used 14 pin IC. Now this is 16 pin IC. In this the output of 7490 will be given as input for 7447. Okay, outputs means what? These are the outputs, right? QA, QB, QC, QD. Okay, these are the outputs. Okay, give it as input for 7447. Okay, so the first output is what? QA. Okay, so QA, do the connection from QA, give it to pin number 7. From QB to pin number 1. From QC to the connection from QC to pin number 2. From QD to pin number 6. Okay, so outputs of 7490, that is QA, QB, QC, QD. So we given as input for 7447, that is A, B, C, D. Right. Okay, so we have to give VCC and ground for the 7 segment IC. Okay, in this pin number 8 is ground. Okay, and 16 is VCC. Okay, since it is 16 pin IC, okay, 8 is ground, 16 is VCC. Okay, so to work this as 7 segment, we have to short 3, 4 and 5, and we have to give it to VCC. Okay, short pin number 3, 4 and 5. Okay, so just short pin number 3, 4 and 5. Okay, so you have to give it to high voltage. Means just you connect that to VCC. From 5 give it to VCC. Okay, so now we connected output from this to this. Okay, so we given input here. Now we have to take output. Okay, so output of 7447, so we have to provide for this 7 segment display. So we can observe output here. Okay, so from pin number 13, okay, so connect to input A. So 7 segments you have, right? Connect to segment A. From pin number 12 to B. From 11, okay, to C. From 10 to D. Okay, next from 9 to E. Okay, so next we have pin number 15 to F and pin number 14 to G. Okay, so this DP is decimal point. Okay, you can leave since we are displaying just single digit number. Okay, so you can see 0 1 2 3 4 5 6 7 8 9. Okay, so it continues. Okay, so whatever the binary values, right, so which is displaying here, the same equivalent 7 segment you can observe in this 7 segment display. Okay, so this is about this experiment. Okay, you have to display binary as well as 7 segment. Thank you.